Hello and welcome to SAS Bootcamp Week 6, Video 1. If you've made it this far into the bootcamp, first of all, congratulations, because this is the last week of content in this bootcamp. This is it. Once you learn all of this, you should, in theory, be able to go out there and do your own health outcomes or health services research projects, right? In today's week, we are going to learn 4 different topics. All of these topics are actually really simple, but every single one of these is extremely critical and important. The topics that we are going to learn today are topics that I've used in almost every single research project I've worked on within SAS. But despite them being so important, they're actually really simple to learn and very simple to implement as well. So I'm going to be moving through some things pretty quickly today. We're going to learn descriptive statistics. We are going to learn about how to take means, standard deviations, how to calculate frequencies, run some crosstabs. We're also going to explore proptabulate in here. Next, we are going to do hypothesis testing, some very basic hypotheses, including chi-squares, students' t-tests, ANOVAs, and a linear regression example. We will then talk about plotting data in SAS using proc-sgplot and proc-gplot. We are also going to cover mapping in SAS, which not many people know that you can actually create some pretty nice looking maps within SAS. We'll finish with output display system, and then we'll talk about macros, which is a really important portion of SAS as well. In this video, which is video 1, we are actually going to do the first of these things where we are going to talk about descriptive statistics. So without any further ado, let me get started. I'm going to share SAS Studio, and we're going to jump right into this week's content. All right. Hopefully you can see SAS Studio on my screen right now. I've already run the libname. This is the week's code file, which I've already uploaded to SAS Studio. So you should have access to this once you're enrolled in the SAS Studio course. For this week's content, we are going to be working off of a file called m_stat. So let me introduce you to that file first before we start running any other code. This file is actually based off of, I've built this file off of your classes project. So if you've seen the project that is due at the end of this bootcamp, we've talked about some real data applications using something called the marijuana status, whether marijuana laws in a given state in the United States are either illegal or medicinal or recreational, which is represented by this variable m_status. And we've got some other variables in here, which I'm not going to go over all of them. But we know, for example, in each state, if there is a PMP, which is a prescription drug monitoring program, we know what percentage of those states individuals are under 30 years of age, what percentage of them are abusing alcohol, what percentage of them have no insurance, which is the INSR variable. And then we have rates of opioid mortality, racial, gender distributions, and unemployment rates within each state. And these data have been provided for all 50 states. So this is the primary file we are going to be using for today's class. The reason I chose this file is because it has an adequate distribution of some numeric variables and some character or string variables, which will allow us to do a little bit of statistics that we can demonstrate through SAS today. So let me begin with continuous variables, right? So when you're working on a health outcomes research project and you want to publish your results, the first thing you'll want to do is, of course, look at some descriptive univariate statistics. For continuous variables, for numeric variables, this is usually means and standard deviations. The way to get that is using this particular syntax that is shown on the screen. The syntax is really simple, as you will see that for most statistics that we are going to cover in this week, the syntax in SAS is actually really simple. In fact, for most health outcomes research projects, I would say that about 80 to 90% of the time spent on the project is actually with data management. So all of the things that you've learned in the past 5 weeks, that's what takes up most of the time. The statistics itself are really simple to run and are only a few lines of code here and there. So that part doesn't take too long at all. Here is the syntax for the means procedure. It basically starts with proc means, and you feed data equals, and then the name of the file. This is exactly like we've looked at proc sort before, except instead of sort, you have to type out means. And then you have to tell SAS what is the variable that you're looking to calculate means for. In this case, that is OP_mortality, which gives the rate of opioid mortality in each of the 50 states in the data set. So I'm going to hit run, check my log, and there's my results output. So by default, This is a little small. Let me see if I can zoom in a little bit. Okay. By default, the SAS means procedure actually gives you 5 different pieces of information. It tells you the number of rows in the data set, tells you the mean of that variable you're interested in, the standard deviation, the minimum, and the maximum. All of which are really useful, but very often that's not enough and you want more information. So I'm going to show a few variations of proc means first before we jump into calculating percentages or other frequencies. The way the options for the proc means procedure are really, there are a lot of options. We are not going to cover all of the options, but I'm going to cover some of the more common options that I've used as part of research projects, and we can talk about how to apply them. The first option that I find most interesting, most useful, is asking SAS to give you statistics other than just the mean, standard deviation, minimum, and maximum. The one that is most useful for a continuous variable is actually percentile statistics and medians. So if you want a median out of the proc mean statement, you just have to write the word median right after you write the data set name. You can also write mean and standard deviation if you also want those to be outputted. And then there are these P options, which basically give you whatever percentile you're interested in. So P5 will give you what is the 5th percentile for the opioid mortality variable. P25 will give you the 25th percentile. P95 will give you the 95th percentile. So you just write that in right after the dataset name, and when you hit run, you'll see that it gives you, I'm zooming in so you can see on this video, you'll give you mean, standard deviation, median, 5th percentile, 25th percentile, 95th percentile. Right? Very simple. The proc means procedure also has a where statement that is an option. The where statement in a proc means procedure works exactly like you would expect, right? In a data step or in a proc SQL, for example, we learned that a where statement is used to subset a data set or delete certain rows. In proc means, it does the same thing. If you have a condition written after the where statement, SAS will basically implement the where statement first before it calculates the mean or any other statistics on the opioid mortality variable. And you can see this works from the n number in the data set. So if you remember, the n previously when we ran proc means was 51. Well, right now we have a where condition which actually deletes 26 of those 51. So you have only another 26 rows of data left. Another 25, excuse me, were deleted. Other things that you can do with proc means is you can include a class statement. The class statement is actually really, really useful. And I find that most often when I am running proc means, I will use the class statement often in conjunction with the median option or the P25 or the P75 options in order to calculate interquartile range. What the class option does is it tells SAS that you want to calculate the means for that variable of interest, but you want to calculate it in 2 different groups. And the groups in question are defined by the m_status variable. So in the class statement, you need to feed SAS one variable, which is basically a categorical variable. It can have 2 categories, 3 categories, or 5 categories, but it cannot be a continuous variable. If you feed SAS a numeric variable into the class statement, it will assume that every value of that numeric variable is a different group of individuals. So you might end up with 3,000 groups if you have a variable in here, for example, which is numeric and which has decimal points. It might not give you what you want. So make sure that the variable you feed into the class statement is actually a categorical variable with 2 to reasonable number of categories, if you will. All right. So now you see here, the output actually contains the same piece of information we had earlier, except it is now broken down by the m_status variable. So m_status 0, here is the mean, standard deviation, minimum, and maximum. For m_status 1, you get the mean, standard deviation, minimum, and maximum separately. If you want to get these pieces of information, the mean, the standard deviation, minimum, maximum, there are actually other procedures you can use other than just means. Means is a really popular, common way to do it. But there are 2 other ways to get the same piece of information. One is called proc univariate, the other one is proc summary. I'm going to demonstrate both of them here, but really proc univariate and summary are very useful and have capabilities beyond just calculating the means. Right? For example, proc univariate can actually help you do some hypothesis testing, and we can talk about that later. And proc summary and proc univariate both can be used both with numerical variables and with string or character variables. The reason that works is because proc univariate will understand if the variable you are interested in, if you want means and standard deviations, or if you want percentages from them. In this case, I'm leaving proc univariate to run with just the defaults, in which case it will give you the means. So let's run this and see what it gives us. So univariate is a really interesting and useful procedure, because in this case, univariate run with the class statement gives you the same output that it would have usually given, but within each class of the m status variable. So here m status equals 0, and univariate tells you then n, the mean, standard deviation, skewness, the kurtosis, standard error of the mean, and a lot of other information, including all these quantiles here. Proc univariate is actually super useful also if you want to test if a variable is distributed, if it has a normal distribution or not. You can do all of those tests using proc univariate. I'm not showing all of those examples here. If you're interested in what other things proc univariate can do, just go to the SAS website or go to the help feature within SAS and look up all the other options that you can input within proc univariate to run those things. The proc summary is similar to proc means. It gives you n, mean, standard deviation, minimum, and maximum. So it's not as informative as the proc univariate procedure, but it is different from proc means in the sense that you can even feed a categorical variable into proc summary, and you can ask SAS to give you percentages instead of means or standard deviations. It will work just the same. The next descriptive statistics that we are going to see is frequencies, right? So just like means are for continuous variables, when you have categorical variables, you want frequencies. You just want to know what is the percentage of times 0 or 1 occurred in this variable. So we are going to look at the m underscore status variable, which just has the value 0, 1, or 2, where 0 actually means marijuana is illegal in that state, 1 means marijuana is medicinally available, 2 means marijuana is recreationally available. So you'll see that the syntax is still very similar to proc means. You just write proc freq, and then you feed the data into the data equals option. And instead of VAR in proc freq, you have to write tables, not VAR, which throws people off from time to time. So be careful, you have to write tables here. If you write the VAR option in proc freq, it will throw you an error. And there it is. So m status was the variable we fed into SAS. It will give you a frequency and a percentage. So 0 appeared 26 times in the data set, which is 50.98%. And 1 appeared 25 times, which appeared 49%. The value 2, which was recreational marijuana, actually did not appear in the data set at all. That's because we are not using the most recent data with regard to marijuana's legal status in the United States. The useful thing about proc frequencies is you can also request crosstabs. Crosstabs are where you look at frequencies for one variable as distributed by another variable. In this case, I'm just going to run crosstabs with the second variable here using the asterisk operator. The asterisk basically tells you that, tells SAS that you are interested in how these two variables are distributed amongst each other, if you will. So you can see here, this is the output from the proc freq when you are requesting a crosstab. The m status variable is distributed on the left as rows, adjacent m status is distributed on the top as columns. And that's because we requested m status multiplied by adjacent m status. If you flip the order, the rows and columns will also change. These tables are a little busy. I usually don't like asking crosstabs with the default options. We'll talk about some other options in proc freq. But it gives you the number, which is the 6 here, and then it gives you three percentages. It will give you a column percent, a row percent, and a total percent, right? So the column percent is 6 divided by 11, which is 54.55. And then the row percent is 6 divided by 26, which I believe is 23.08. And then the total percent is 6 divided by 51, which is 11.76. So for each cell, you get a total percent, a row percent, and a column percent. And you need to decide which one is more meaningful for your study, right? If you are trying to just input these, interpret these numbers and these percentages for the purpose of your understanding, I have found that having all three of them being displayed in the output actually gets really confusing. So I will use these options, no row, no col, and no percentage, to basically suppress a certain percent. So if I input all three of these options right after a forward slash in my previous syntax for the proc freq, you'll see it will give me just the numbers with no percentages. right? Just the numbers. But usually that's not what I'm looking for. I might want row percent, but not column or total percent. So I'll just have the no col and no percentage. And it will give me just the row percent in this case, right? 6 divided by 26, 5 divided by 25 is 20, so on and so forth. The other thing to observe in this proc freak step that I've done is I've actually calculated crosstabs for m status with two other variables, adjacent underscore m status and pmp underscore status. And to do this, I could have done it two different ways. I could have just copied and pasted this. So for example, I could have written m underscore status. So I could have written these 3 lines of code, right? And it would have given me one crosstab like this, and one crosstab which is m status by pmp status. So that's one way to do it. But if you want to be more efficient with your crosstabs, you can just use parentheses. And SAS understands parentheses followed by the asterisk as basically that you want m underscore status as your row variables. And here are the 2 variables that you want crosstabs with, and both of them will be columns in that output procedure. Procfreak is super useful. Procfreak actually also has a lot more options than I'm showing right now in this video. I will let you explore those options on your own, however. The one other procedure that I do want to introduce when it comes to particularly frequencies is proptabulate. Proptabulate can handle a variety of options, and proptabulate is actually incredibly powerful. It takes a little bit of time to learn and get used to proptabulate, but I've found that proptabulate makes your output look so much better. If there is one thing you've identified within SAS by now, it's that SAS output is usually not directly built to go belong in a manuscript or a poster or any kind of presentation, right? So if you're working on a project and you want the results to be formatted appropriately so that you can directly copy and paste them into your manuscript, you'll have to put a little bit of work into it. And really, that's not a new thing in SAS. The output in SAS not being presented well is a problem that has been around since SAS has been around, right? So they've started to introduce new options to make your output look more presentable, to make it look a little more pretty. Proptabulate is one of those procedures. Proptabulate is helpful because it lets you take the output that we previously generated with procfreak and procmeans, for example, and it lets you really format those tables any which way you want. Here I'm demonstrating how to use proctabulate to create a really good looking table that you can, in theory, copy and paste into a manuscript. So look at this, for example. Let me see if this works correct. My log looks okay. In my results, you'll see I basically requested a breakdown between m underscore status and pmp status. And I actually asked for the n number and the row percentage here. So the way I've done that is I've used m status in the class variable. All the variables that I want in my table have to be listed in the var statement. And then I follow that up with the table statement. And the table statement is really what tells SAS how you want the tables to be broken down. And within the table statement, for example, you can list all the variables you want separated by a comma. The comma basically tells SAS what are the variables you want to see as rows, what are the variables you want to see as columns. So here I want m status in my rows, and I want my columns shown as pmp status. And for each variable, you can list what statistics you want to see. So in this case, I want to see the total number n and column percentage. Earlier, I had row here to get the row percentage if you want. This lets you really add on multiple variables and make your table look interesting, if you will. So let me do one more here. So if you want opioid, let's see. I'm going to add another categorical variable here. And we'll go with the default, see if this works. Okay, so as default, now I've added a second variable to my columns. The rows are still m status 0 and 1. What this will give you as default is a sum. If you don't want the sum, if you want n or percentage, you can always add the asterisk, and within parentheses, you can include what you want to do. just like we've done for PMP status here. So proptabulate, I wanted to introduce because I think it is very powerful. It's not something I've used super often, because I found that even when using proptabulate, sometimes there is a steep learning curve that steep experimentation curve, excuse me, that I found to be not worth my time always. But for some really simple or neat tables, you can get that out of proptabulate without putting in much more effort. So I'm going to wrap up this video for now. We're going to come back and we're going to look at hypothesis testing within SAS.